Hey mathematicians, in this video I am going to show you how to solve a problem similar to a bonus opportunity that you are going to have on your upcoming mastery. And we are doing something called linear programming. And it's basically just a way of using inequalities to represent real life situations. And so apparently Fred's got a coffee shop, gives you lots of information about like how much he charges for the two blends that he sells and how much of each type of bean is involved in making each blend, how much he gets delivered every day. And our goal in this problem is to do something called profit maximization. Like, why are you in business? Probably more than likely to make money, right? So we are going to use math to figure out how much of the house blend he needs to make and how much of the exotic blend he needs to be prepared to make in order to make the biggest profit possible. So the steps are going to, are extremely familiar to you at this point for most of this, okay? So our two unknowns, our two things we're trying to figure out are house blend and exotic blend. I'm going to say house, number of pounds for X. I'm going to say exotic for my Y, although I really could have done it either way. I'm going to skip this. This is the part you don't know how to do yet, okay? So I'm going to skip that for the moment and go down to the part that you do know how to do, which is writing inequalities that represent the constraints. And remember, the constraint just means what are his limitations here? And so where do we see anything that relates to a limit? Well, he's limited by how many beans he gets, right? So he gets 200 pounds of Costa Rican beans delivered every day and 330 pounds of Ethiopian beans. So 200 is going to have something to do with that constraint for Costa Rican, and 330 is going to have something to do with that Ethiopian. And then if I go back up here, what else is that has to do with that supply line? Well, for the Costa Rican beans, it's half Costa Rican, the house blend is half Costa Rican, the exotic blend is a quarter Costa Rican. So we are going to use that to write the other half of our inequality. So half of the house blend is Costa Rican beans, so that's why it's 1/2 X. And then 1/4 of the Costa Rican, or of the exotic blend is Costa Rican. And he can't use beans he doesn't have, right? So however much he makes over here has to be less than or equal to 200 because that's all he's got to work with. And then our second limit has to do with Ethiopian beans. So the house blend is half Ethiopian beans. The exotic is 3/4 Ethiopian beans. So we are going to use that to represent this equation, and again, or inequality, sorry. And again, it's got to be less than or equal to. Okay, there's also something in real life situations that we call common sense constraints. And that basically just means that, and typically it involves 0, 0. What that means is just that you can't have negative beans, right? So it just means that your X value has to be greater than or equal to 0. Your Y value has to be greater than or equal to 0, because we are trying to figure out number of beans and you can't have negative beans. So that's why it's typically called like a common sense constraint. So let's graph this. That's why the graph only has positive values, because there's no reason for us to have any negative values, and it's because of that common sense constraint. So I am going to use intercepts to graph my two inequalities. The first one, I get my x-intercept is 400, my y-intercept is 800. We know we're going to connect it with a solid line, and we also know if we do a test point that 0, 0 does make that inequality true. I know I'm going through this part fast, so ask me in class if you got a question, but we've been graphing a lot of these at this point, so I'm kind of hustling through that part. So that's our first one. And then for our other one, our x-intercept is 660. Don't get too hung up on, perfectly estimating exactly where that is. It's a decent estimate. And we know that I'm going to connect my coordinates. And we know from me doing a test point that 0, 0 is a solution, which means that we are going to shade under the line again. So now that we've graphed our system of inequalities, where's the area that we are interested in? We know that it's this spot right here where we have this overlap, right? So this is where because all we've done to this point is just said, hey, there's a solution that falls right into that shaded region. Now we're going to show you how to do something more specific with that. So notice that the shaded region forms a polygon, like a flat shape. And the polygon is made up of these 4 corners, right? These 4 vertices. So we need to know what the X and Y values are for each of those corners. And I don't really like how they call this intersection points. I see what they're saying. I'm not a huge fan, but I mean, it's fine. So the first little dot, the first spot on the graph is 0 and 440. So that's the first little like corner of that spot. We've got our common sense, our little corner right here at 0, 0. We've got our intercept over here at 400 and 0. And then our last one is this intersection point. And the way that I would probably find that intersection point is, since both of these are in standard form, even though they're inequalities and not equations, you can still solve by elimination. So I would probably like pick an equation and multiply everything by -1 so that it cancels out those x's, and I would go from there. But however you want to do it is all good. And I'm going to assume you've done that part, and you might want to actually like try that out yourself. And you should have ended up, if you did it correctly, you should have ended up with the ordered pair. It's a little bit of a goofy decimal. 257, I'm just going to round it to 1 decimal. So 257.1 and 285.7. So those are our 4 little corners of the space where it overlaps. So how do I figure which? Now, common sense is probably going to tell you this one is obviously not going to be the answer, right? Like, that's not going to maximize your profit, because if you don't sell any coffee at all, or you don't prepare any, obviously you're not going to make any money. But what about these other 3? So how do we figure out which of these possible combinations, one of these represents his maximum profit? Maybe he doesn't sell any of the house blend and he only sells 440 of the exotic because that's more expensive. Maybe that maximizes his profit. Maybe it's here. Maybe it's here. Okay. So how do we go about figuring out mathematically which one it is? So let's go back up to this equation that we skipped. And we're looking for the equation that represents profit. Well, we haven't done anything with this yet. How much he charges for each blend. And that is going to be our profit equation. So since he sells the house blend for $3.50, I'm just going to cut off the 0 to make it shorter here. So that's going to be 3.5x. He sells the exotic for $4 a pound. And that needs to be equal. They told us to use Z for profit. So we're going to use this profit equation. So this 3.5x plus 4z, plus 4y is equal to profit. And we're going to take each of these points and substitute it into that equation to see how much profit we get with each of those combinations. So if I don't sell, so if I put in 0 for X and 440 for Y, and I do the math, that is going to get me $1,760 in profit. Obviously, this one is going to give us, if he, doesn't make or sell any coffee, that's going to get us 0. Now I'm going to put in a 400 for X and 0 for Y. And that gets me $1,400 in profit. So far, that is not our max. Last but not least, if I put in 257.1 for X, 285.7 for Y, that is going to get us around 2,042. Oh, you know what? I just realized I should not have. Let me put the 4 back in here because we're talking about money. So I really need to use 2 decimal places. So I'm going to put in 257.14 instead. So that gets me profit of $2,042.79. So which option would maximize his profit? You guessed it. It's going to be this one right here. So to make the most profit possible, he needs to sell 257. Obviously we can't sell, I guess you could sell a portion of a pound. But that is how much of each blend of coffee he would need to sell to make the biggest profit possible. So let me know if you've got any questions. There's another practice problem that is very similar to this exact one on ClassKick. And I've also given you some extra practice too. So let me know if you got questions.